my intention or my hope is that at the end of the meeting, you should have an idea of why a random internet user would utter such words. Like it feels very controversial. But before I get into the weeds of it, maybe just a short description. I know Samuel already said most of it. But again, my name is Jeremiah Obama. If you can't pronounce the name, just say Jeremiah. That's fine. Um, yeah, I have been doing this for a while and I really enjoy doing it. One of the things I enjoy the most is actually finding out how things work and then either breaking it or making my own version and never releasing it. But this is one topic that I found very interesting in the sense that it's small, or it could be seen as small, but it also has like serious impact on how you basically architect your app around it. And um, when I started writing Flutter, it didn't exist. Mostly you just use the normal way you would do it, which is what we would do today. And then eventually it came out and it became very popular. And it also became very bloated. But I won't talk too much about that. Let's just get into it. Again, you don't need get it. Also, you could find me. I don't have an introduction page, but you could find me on Twitter, randomly tweeting or retweeting stuff every now and then. Sorry, X. You could also find me responding to comments sometimes on WhatsApp. And yeah, I also star repos on GitHub, so you could follow me to see what I star. All right, you don't need get it. Very controversial. And I also say controversial because if you go to the pub dev and search for get it, maybe the numbers would have changed. But when I made this presentation, because I've given this presentation before internally in my company, this was what it was. And even at like this, it's still a bit quite impressive, if I do say. First of all, it's very hard to get 3,000 likes on PubDev. And trust me, I know for sure because I have packages and I don't think anyone is up to 3,000 because it takes a lot to basically install a package, use the package, like the package, go back to PubDev, log in, and then like the package. So to get 3,000 people to say, I like it, it is quite impressive. Plus, of course, 100% popularity. You can't get higher than that. There's a few libraries that are 100%. So it is quite popular and it's very well used. If I give a rough estimate, I would say maybe in the tens of thousands. A lot of people use it, both on small, medium, and very large projects like the one I work on at my company, because we also use Get It. But why then would I have the audacity to actually say you don't need Get It? It's very popular, obviously. And this is basically why. What you're looking at now is a screenshot of a benchmark that I ran some weeks or months now ago. You can see it's a long time ago now. And this is comparing Get It from Flutter community, which is a big deal, and IoT container from our very own Melbourne developer, Christian, who I've had communications with over this same topic as well. And finally, a package from a random guy called Joe Bombs, and it's called registry.dat. And these are the versions I used as at when I ran this benchmark. You could see the numbers in microseconds. Keep that in mind. This is microseconds, which means it is really, 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 really tiny. Uh, but being tiny doesn't actually mean it's useless. It's not a useless figure. It actually tells something because this is almost, we're looking at from get it to registry, almost 10 times, well, 10 times slower. I won't say faster, but slower. And you do have to ask the question, or at least it begs the question, why? Like, what exactly does it do? Why does it take so, well, not so long, but why does it take relatively longer than the other thing? And if it has feature parity, then seriously, what exactly is going on? It begs that question, at least it begged the question to me, and also to a Melbourne developer who I will call Christian from now on. And he has a package for this same the same concept of locating service. And it is also feature parity with Get It, and it's obviously 5 times faster, or at least Get It is 5 times slower than it. And it's the only other package I would recommend. I haven't really done a benchmark for all the packages, but at least for this three, I would say IOC Container is like the most sensible thing. I have also read through it, and it's really straightforward, just like what you see today with registry. By the way, I'm Bombs, if you don't know. And yeah, this is why I have the audacity, basically, and I just told you my hand. But again, when I saw these numbers for the first time, it actually gave me like a scare or like a fright. I knew Get It was polluted, but I didn't know how seriously it was. I could also explain why it is, but we'll skip that for now. You could find out yourself when you look at both implementations and maybe try to find the bottleneck in why Get It is slower than any other thing out there. But this was my honest expression. I was a bit like, okay, what? How? Like, what the is going on here? And it just blew my mind for a bit, and I had to like dig into it even more. And you might ask, if at least the question I was asking myself, is this some kind of magic or sorcery? Well, the simple answer is no, it's not. You could see it in the slide. I didn't even do any fancy animation or anything. It's basically no, it's just straight up logic. And the service locator should really not be that complicated for what it is. This is not an argument to use service locator. That's another conversation. But for this context, in the sense that there is a library that is popularly used that basically implements a concept and does it poorly, then it is something to consider, even if not for yourself, but at least for the bigger community at large. You could save the world by, or save the planet by minimizing CPU stress by basically just switching away from Get It if you want. But I'll add this caveat or disclaimer that this whole thing is not to say to use registry or to ditch Get It in your big app, because small apps, big apps, the impact might be minimal. So you won't see this, again, microseconds. But it does add up and it does beg the question, and that's why we're here. So how do we do this, or how did we get here? And this is the end of the presentation. If you have questions, you could also ask them now, because the next thing we're doing is we're going over to see some code. So there you go.
Hello.
Yes.
Hi, Jeremiah. Um, yeah, so this is Franklin. I just wanted to ask, how did you run the benchmark and test them
Okay.
with each other? Yeah.
I will show you at the end. Well, I'll show you because now we're about to start coding. So
Okay.
you'll see how it actually works. If I could find my window. This is a very complicated UI. Let me see. Okay, can't find it. So I'll share the whole screen. Uh, all right. Can you see my entire glorious screen?
No.
No.
No. Okay, I'll try again. Share. All right. Should be visible now.
And yes.
Yes. All right. So is this big enough for everybody to see? Should I zoom in a little bit more?
Yes, you can zoom in a bit. A bit tiny.
Okay, good,
Okay, yeah, that's fine.
good. All right. So this is a simple workshop GitHub thing I made just so that we could speed up the initialization step. But this is basically just a simple dat package with a lib folder, a test folder, a pub spec, YAML, really nothing here except for meta. And dev dependencies, you would see lint, test, excuse me, benchmark harness, get it, and IOC container. These are dev dependencies because, yeah, we have to do the benchmark against the actual repo, against the actual package. But there's really nothing else here, so I'm not cheating in any way. And after that, so I have this API, which I feel, except for one API, covers everything you would need to do in a service locator. And if you feel like something is missing, you could say something at the end. But I figured, at least in most of the use case I've had to do on my projects and projects from other people and company projects as well, this is the feature set of things that we actually use. It's missing one major thing, which is scope or scoping, but it's rarely ever useful. So I never really had to actually use it myself. And yeah, sometimes I just don't see the need for it. But this is what it is. And we have a set, we have a get, we have factory, we have lazy, which calls factory with a boolean called true, and we have replace. And we also have a type def here, which is a function that takes a type and returns a type. If you look at this, it is identical to get. So where this is used is for the factory. And if you read this, it's basically a function that takes a registry factory, which is this, which, as you know now, can be substituted with this, and returns a type. So that's just what it is. That's a factory function. So that's all there is to it. And everything is unimplemented now, and we're going to do it TDD style. Sometimes it works, sometimes it's nice. I'm not saying to use TDD for everything you write, but in this use case, it actually makes sense because we know what we're trying to build. We know exactly what you should do, and we just want to fill in the blanks. So this is also a good example of how TDD works, if you don't know. These are the tests, and we'll just go through it one after the other for each of the API. So set should work as expected, which means you can set a value and you can get the value based on the type, and it should just work. And it also throws an assertion error if you try to set a value to the same type multiple times. You already know how this works. I'm sure a lot of people have used the service locator. And if it's basically there before, you just throw an assertion error and you have to catch it, or you have to know that that's how it works or behaves. There's also replace. It's an internal API, which you know by this tag, which means you can't actually use it outside. It's an internal thing that is just there. And the whole point is that it's able to replace anything at any point in time at runtime. This is internal because personally, I feel it doesn't make any sense to change your dependencies at runtime, at least after registering them. So yeah, I think it's a bad practice, but don't take my word for it. I rarely try to replace my dependencies after registering them. But again, internal. And it should also be able to replace factory methods. So if you register a factory for a type and you try to replace it, it should also replace it when you try to get it. And factory, sort of already know how it works. It's just a factory. Anytime you set a factory and you get the factory, it is evaluated again and again and again. And it's basically computed unlike sets that is a singleton. So every time you call get for the type, which in this case is a double, and in this case the string, it would compute it over and over again every time. Lazily, of course. So not when you register, but when you actually get it. Yeah, get it. It's in the name. Then it also throws an assertion error if you try to set the same factory again, which makes sense. You shouldn't do that. And it also throws an assertion error if it was set as a singleton and now it's about to be set as a factory. Basically the same thing. And then one important thing is late initialization, which means regardless of how you register your dependencies with either factory, lazy, or set, anytime you try to get it, you should always evaluate. So the order in which you register it or when you register it doesn't really matter. It would always evaluate as long as it's registered somewhere. And that's all for factory. And lazy is sort of identical to factory, except it's a singleton, which means it is only computed once. So it is a factory, yes, but it's only computed once. And this test basically shows yeah, that the call count doesn't increase when you try to get it multiple times. And for every other thing, it works just like the factory supports. You get an assertion error, and it also supports late initialization. So regardless of how you arrange it, it would always just find the stuff. And just writing tests, forget it, because just for completeness, because again, all the other tests here use get in one way. But again, just for completeness, it allows you to get stuff after setting stuff. It also works with type inference, so you don't have to declare types everywhere. It just works. This you get for free, but you never really know sometimes. And then finally, if you haven't actually registered something before and you try to get it, it basically fails. If you have been paying attention, you will notice there is no global variables here. Every time the registry is constructed from scratch, because that's the way I think it makes sense. There are no global variables. Nothing is kept in a global registry somewhere. So to prove that none of this has been implemented behind your backs, I will run the entire test suite, and my expectation is it will all fail. Voila. So, oh, sorry, zooming in the wrong thing. This doesn't zoom. Yeah, but you could see it. Everything fails. So with that out of the way, wait, what happened here? With that out of the way, we're going to start implementing it one after the other. And we'll see how far we get. I plan. Come on. No, really. Okay, just going to leave that. For some reason, I can't. Let's wait. Okay. Yeah, let's go. We'll start with set. Already, maybe if there's a question you could just ask.
All right. Thank you. So my question is, you said there are no global variables in your test, so you just have any registry from scratch every time. Does it work the same way if you have a setup and tear down, and then you use the same instance in both of them?
Well, technically, yes, it will. So you could also just have one instance here, and basically whenever it tears down, you reset it. But as you can see, there is no reset method on the registry. You could also just, I could implement reset, and reset would clear whatever instances we've saved. So that's one way. But yeah, for the sake of this, there's really no point, but indeed, we could do it that way as well.
Thank you.
All right. So without further ado, we're going to begin. So a service locator is basically just a way to say, I want to keep something in memory, and at some point in the future, I want to be able to retrieve it. So a typical data structure you would use to do that is a hash map, because it makes sense. You can keep things by a key, and then you could always get them at very instantly when you want to get the value back. So that's exactly what we're going to do now. We're going to create a map, and we'll call it instances for lack of a better name. And the map is going to be of type. If you've never seen type before, it's the runtime representation of what the type or what an instance or object is. And the value of the map would be, or the value for the type or for the key type would be of type object. Now, why is it an object? Is because we're going to keep different types of things in there, and there is actually no way to represent types of everything except using an object. So, but we do know that if something exists in here, which means we have called set, or, well, you can't see it now, but which means we have kept it in there. So regardless of what the type is, when we want to get it out, we know that if it exists, then it's definitely of the type that we want it to be, and then we could just cast it back. So a simple implementation for set would basically just be instances. This is my key, and I want you to put this instance in there. So of course, compiler is complaining because instance is of type T. but we could make it conform by just saying it's of type object. And this way, we've implemented set. It's really that simple. And if we want to get the value back, for now we know it's always going to be there if you've called set. So we're just going to say instances, get me the value of this type, of this key T, and the value should be of type T. Like I said, we're going to cast it back to an object. And of course, we need to return it. And this is basically all there is to set and get. Sorry if I disappointed you that this is going to be a lot of bells and whistles. This is basically it in a nutshell. Of course, we're going to implement several things like the assertion error, but in a nutshell, this is what it is. And it shouldn't be more complicated than this. If it is, then something is a bit weird, if that's all it does. So we're going to run the set test again. And something still fails because it expects when you run the set, it should throw an assertion error if it's already registered. So that means if this type already exists when you try to set it, then throw an assertion error. So we could do that easily. Again, I'm running on, sorry, I didn't mention it before, but this is running on the latest version of that. So which means I could do fancy stuff with switch, and I would do exactly that. So if we switch on this value and for some reason it already exists, which means it contains a value, then whatever value it is, then we know for sure that this is already set, and we will throw the assertion error and say already set, and it's of type T, just for sake of it. Otherwise, we are going to do what we did before, which is set the value. So if we run the test again, expectations is it should pass, and it obviously does, as you can see on the right-hand side. So set is done. It's, again, looking at the test cases, if your work is expected, you set the value, get the value. If you're trying to set the value more than once, you get an assertion error. Let me know if there are other test cases we could add here, if you think there should be more, but those are the major ones. And if you walk through it, since we've already implemented get, if you look at the test for get, okay, sorry. If you run the test for get, it also fails because when you're trying to get the value, which is this one, the argument error should be thrown if it's not registered. So we could use the switch case again and say on this, if
Yeah,
okay.
is it possible if you could zoom in a bit? I think there's the others that can't see.
Okay.
Let us know if it's fine with everyone. If it's okay.
Good.
Okay, I think it's good now.
Okay. So we're back to the switch case, and we're saying if this has a value of type, when you're trying to get the value from instances, and it does have something, then we want to basically return that thing, because then it makes sense that the value has already been set. Otherwise, we are going to throw the argument error and say not set. And if you run the test again for get, it should pass. As you can see, the 3 test cases pass. Everything is good for get, so we can move on. The next thing we could do is replace, because it's a low-hanging fruit. It should basically just allow you to replace stuff regardless, which means it's the same as set, but without any guards for, say, the value already exists of something. And what that means is that we could actually then replace this with replace. And that's why it's an internal method. So if we run set again, just to make sure it still works, that's fine. Replace should replace factory methods, but we've not done factory methods yet, so we'll skip that for now. And of course, get should also work. Yes. So in that case, we could switch to factory and let's implement factory. So as you can see, I already defined the type def. So a factory is a function that, well, a factory function, which is this guy, is a function that takes a registry factory, which again is literally the same thing as get, and returns the type. So just to verify that we could do that with the get, if we type function, which is this guy, if you missed it, and pass gets to it, it also just works. So the compiler doesn't complain because again, get is literally the same thing as registry factory. So, but with this, if we leave it this way, obviously, nothing would happen. And every time you register the function or the factory, it would just call it again. So instead, oh, by the way, we should also save the value in the instances. But instead, we don't want to keep this directly inside of it. We don't want to basically run the factory function every time factory is called. So what we could do is to make it a bit lazy and instead do that when we get the value. Because again, for factories, we're only going to compute the value when we get the value, not when we register the value. So this is just keeping it until that time. So that means that we need to expand our get statement or our get function. And if you look at this thing here, this is basically the definition is a function that returns a function that when computed would return t, which is this guy. So that means this is a function that returns t at the end of the day. So that said, we could type our getter to be, if you come across, if you try to get the value from the instances and the type is a function that returns t, which in this case is a factory, then return the factory and just call it. So that means when we try to get a factory function, which would match this, obviously, well, t function that returns t, then at that point we run factory. And maybe it makes sense, maybe it doesn't, but I'm sure if you have a look again, it will make some sense. And that's basically it. So I just ran, what test did I run? Yeah, I'm just going to run factory now and see what happens. So it still fails because, so some text for factory fails. It fails to throw an assertion error when the factory is already registered, which means we should basically do a similar thing we did here with set. So if you try to set a factory again, then it should throw an assertion error that it already exists. So it's literally the same. You could make this reusable if you want, but it's really no need for it. And if you run the test again, then it should all pass, which means factory should work as expected. You can set something and get that thing eventually, and it will compute every time. And it also throws an assertion error if you try to register it more than once. Also tries to throw an assertion error if it's set with a singleton and then you call factory again. And blah, blah, blah. Same for late initialization. I hope I still have time. It's almost 10. All right. And for some reason, lazy also seems to pass, even though I have actually not implemented anything there. But we're just going to check again. And obviously fails because there's nothing implemented there. So lazy is a bit, well, I wouldn't say tricky, but the idea for lazy, like I already mentioned, is it should only compute the factory once. So it's identical to factory, but it should only compute the factory once. And the computation for factory actually happens when you try to get the value. So it means if we use the same type for a factory, we won't be able to decipher which is which, because at this point, we don't actually know what is lazy and what is not. So one thing you could do is you could create another kind of wrapper class that that just makes it different from a function that returns t. because again, the lazy function or the lazy factory is also a function that returns t, at least externally, but internally it doesn't have to be that way. So we could use some trickery with types to make it a bit more interesting. And how we'll do it is simple. So like I said, the lazy factory is exactly the same as the normal factory. So if you forget, I also pass this value here to true when lazy is called. So that's why I'm checking for lazy. So if it's lazy, then we'll just duplicate the same thing first. But there's a problem here because it's an identical definition, but we could tweak this a little bit. So again, this is a function that returns a type. It doesn't take anything, but we could make it smarter. So what if this function takes something, let's say a string and a string of name. So that means if we register it and we try to get it, it would be a function that takes a string. And of course, you have to pass a string to it. And instead of running the factory every time, we're just going to run the factory once, get an instance, and then we could return that instance. But before we return the instance, we could say set the type that we're trying to get as the key to this instance. So that next time you try to get that value, it's not going to hit this guy because you've already replaced it, and it will just go straight to instance. And we already have an internal thing for doing that, replace. So as you can see, we don't actually use name at all because it's just a way to get this definition. We could maybe not actually use a string, and this becomes dynamic if you hover on it. And we actually don't care about the variable called name because we don't use it, and we could replace it with a dash. But this is also dynamic now, and that means this needs to change to dynamic, and this doesn't need a string. It's dynamic, which means anything goes. But because we don't actually use it, there's no point creating anything in memory. We could just pass a null. And because I don't like dynamics much, I could also just replace it with void, which means nothing. We don't actually use it, so we don't care. We just need it for the definition type. And with that, we should have implemented lazy. And the tests say yes, which means we are done. And I'll just run everything again one more time. And of course, we get everything passed. And that was it. All right, maybe that's a lot of information. So we still have about 15 minutes. Do you have any questions as of now? Because we're not done, but we're sort of done with the implementation, at least to an extent. So if you have questions, you could just ask now. Or in the absence of questions, we could move on. So I promised benchmarks because that's why we're all here. The benchmarks was very interesting. So let's see benchmarks. And this is a simple benchmark I made for the 3 packages that I mentioned: Get It, IOC container, and registry. And this is a tool that's, I think, provided by the dev team. So it's free. I didn't have to pay anything for it. And all I do is just import it, implement or extend this base class, and put the thing I want to benchmark. So in this case, I'm creating an instance of Get It, and I'm calling register factory on it multiple times, and also a lazy singleton and a register singleton. And I'm also getting all the values out of it. This is just to make sure that it resolves both the registration and the resolving. And it's a similar API for IOC container as well. Literally exactly the same thing. Factory, lazy, singleton. In this case, it's add, singleton, and singleton Yeah, lazy singleton and singleton. And again, the same thing, get the values when we need to. And the same thing for registry, literally the same thing. And this is how to run the benchmarks. And if I run this now, let's see how glorious that turns out. Is it big enough? I'll take the silence as yes. So as you can see from the benchmark I shared, it's almost identical. Again, microseconds, be aware of that. So get it runs in 76 microseconds for the iterative running of the benchmark. IOC container, like I said, 5x. And registry, surprisingly, is not 10x. Something must be amiss. And if you sort of know the answer, then that's pretty good because it means you already looked at what registry is before this meeting. But I will introduce you to something else. Well, first of all, let's run it again just to be sure. So you know there's no caching of sources or anything. And again, almost identical, still not 10x. I promise 10x and 10x you shall get. So if you go back to the registry, I want to introduce you to a new construct, or maybe if you've never seen it before, and this is your first time. It's called, simply put, expando. It doesn't really expand anything, but it's sort of like a data structure that resembles the map. Because if you noticed, I just replaced the map with expando and nothing else changed, which means it allows you to get values out of it, like a typical map. And it also allows you to set values to it, like a typical map, and nothing weird happens. So just this replacement, yeah, of course, there's more information on Expando, which you could look at. In fact, what started this whole project was me trying to understand or find use case for the Expando. And this was one of the use cases I found. And I was impressed that it actually shaved off a couple of microseconds, again, microseconds of the entire runtime of the thing. So we're going to run the benchmark again. Mind you, this is 9. And if you run the benchmark again, there you have it. We eventually get our 10x just by switching a map to an expander. So there are some caveats because the expander doesn't have all the use cases or all the feature sets of a map. If you look into it, you would see it only has a way to get the string representation, which it's literally just expander and the name of the expander that you get to it, and the operator to get or to get and to set, and that's all. So you can't actually do anything more than that. You don't have a way to get all the keys. You don't have a way to get all the values. You can't iterate over it. You just get it and you set it, and it's perfect for our use case. And just by switching to it, we shave off 2 microseconds, which is very, very meaningful. And yeah, that is the end of this. I have a bonus at the end. Well, at the end, because this is not the end. But if you have any questions regarding this, you could ask. I would also share the links for your consumption afterwards at your own free time. But if you have a question, please shoot. Or in the absence of any questions, then I'll continue until I call it a
Yeah.
final end.
I think there are questions.
They are.
Damn. All right, go ahead. Or should I read the questions? Is it somewhere? Should I stop sharing? Is it written down or people want to speak?
I mean,
So, put on. Right. So from the explanation and from what you've shown us, the registry can do the different functionalities of what it's supposed to do. right? And
Mhm.
like you said, a lot of people uses getting big projects and smaller. Like, so are there other use cases where we would need to consider getting on a registry? Are there other things get it can do that registry that you show on does not, or some other service?
Yeah.
Yeah.
Yes.
So
There
what
is.
if there are any, what are those things that would make us consider get it over just using this?
Yes. There are two major things that basically there's no feature parity for. Is Get It allows you to do something called scoping. So which means you could register all your dependencies, create a scope and like a child, Get It, and then register things in that child, which means you can then you can only access those things you register from that scope. So whatever you register in the scope, it doesn't propagate upwards, but whatever you've registered in the parent, you can always get in the scope. So a typical use case for this, which yeah, actually, we've actually had a use case for, is maybe you have tabs, like tabs on your home screen, and for each of the tab, you actually want to have like different types of dependencies registered, but you also want to share some dependencies across the tabs. So this is a use case that I could see for you using our scope. Otherwise, yeah, it's really nothing else. And the other thing it allows you to do is to register lazy async factories. So factories that are asynchronous by default, but I think when you get them, it already processes the async state so that you could just get it as though it was a regular thing. But then you have to sort of, I think it has a property that allows you to wait for everything to be ready, which, yeah, it has its use cases. I personally don't put async stuff in my registry because I feel like if there's anything async I need to do, I could keep it in the main function and allow the splash screen to wait. But this is per use case. So it depends on the app. The app, you might want the user to actually get to the app quicker and see the app quicker while the dependencies are loading in the background. And then you show like a spinner. So the user feels like, oh yeah, they are in the app. Unlike when you put it in the main function and you're waiting for it, then it's just keeping the splash screen a bit longer. It's a use case thing. And we've had to do that sometimes, but we ended up reverting it. But yeah, it depends on what you want. So you could do that or not do it. I think those are the two major things that are not available in registry. And again, I'm not telling you to use registry. The whole point is just to see that, okay, maybe you should reconsider using Get It, or maybe this would basically inspire you or maybe make you want to know how things work under the hood and to see if there's something you can do. So I could think of contributing to Get It, which I'm basically passing the mantle on to you. So you now could think of contributing to Get It since you know ways of improving it. And I think for me, that's the major takeaway from this conversation. Not necessarily to use registry. Again, you won't find it on PubDev. It's on GitHub. It's not meant to be consumed by everybody. I only use it myself. Maybe someone uses it. I have no idea. But it's on GitHub. You could fork it, you could start it, you could use it, whatever you like. But it's not supposed to be a replacement for Get It. There are other tools. Again, IOC container is probably the closest to I think maybe, again, from my benchmark at least. I didn't benchmark every project, but it's probably something that you could consider. All right. Fine. Should I press something? Open queue.
I think that's where you see everybody that has
Okay.
raised their hand.
All right.
Okay, so thank you for this. So literally eye-opening, and you've already answered part of the question I have, which is initially you said that the time difference in the benchmark is actually like a logic problem in Get It. So I was wondering, like, is it something fixable that doesn't break the apps that depend on Get It, or it's like a break and change if you have to implement it on Get It?
I didn't try to because again, it's 100% popular. which means a lot of people use it, and I would not like to break their project. But what I did was I shared my findings with Christian Findlay, the guy, the Melbourne developer guy that built IOC Container, because I could reach him, and I told him, or I shared with him, how IOC could also maybe get a speed bump, because I also read his implementation, and it's so just as simple can be. So it's easier to upgrade that than try to upgrade Get It without affecting everybody. So I don't know what I will break. Of course, I think they're a test, but yeah, it's up to you now. Now you have this information, please do it. But for me, yeah, there was no actual gain at the moment, so I haven't considered it. But I did share my findings with every other person that cared to listen. So that's it is what it is.
All right. Sorry, this is Michael. I have a very, very dumb question to ask, but let me just ask
There are
it.
no dumb questions.
All right. So I saw before you had a 9 point blah 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 blah. The moment you now move to expando, it's moved to 7 dot blah 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 blah. So I just want to ask, in terms to other packages which you run the benchmark with, do you feel expando gave you a much more edge in terms of the whole implementation to other guys, or um it does feel this benchmark is just basically from your code itself? Like Expando doesn't have anything to do with it in its entirety.
Yeah, that's one thing I didn't verify. And that's again why I said I shared my findings with Christian, because I feel it's easier for him to implement, because I did look at implementation. And one of the drawbacks, like I already mentioned for the Expando, is how you can't actually iterate over its keys. Because there are no keys, you can't actually find the keys. Everything is basically kept external, like you saw the source. So I don't actually know what it's doing under the hood. But there's one thing you can't do, which is you can't iterate over the keys. You can only get and set. And for most, I think for Get It and for IOC Container, they need access to the keys to implement scoping. So I could implement scoping differently in my own library. Oh, I called it a library, sorry. In the registry, without actually going over the keys. So I wanted basically someone else to verify that assertion. I don't actually have energy to do it myself, but it would be interesting to see if it doesn't actually add anything. Because like I showed you, the only thing a service locator should do is what I just showed you. Set something and get it later. And then around it, you could add guards and stuff and lazy and factory. But at the nutshell, it's basically just setting and getting. If you have to do iteration over keys, then something is odd, at least in my opinion. So just replacing the map with an expander added extra 2 seconds or 2 microseconds, and it was consistent. So it means something is definitely going on there. So that's my opinion. But it would be nice to actually try it out on the other packages, like I said, and see if something actually happens. But you might need to refactor a lot, maybe a handful, because again, they have to iterate over keys and possibly over values as well. So it will be hard to remove that without actually knowing what you're doing. Any other question before I show the bonus?
Hello, Jerry.
Yeah, it sounds like a very familiar voice.
Yeah. Yeah, thanks for the great question.
You're
So yeah,
welcome.
my question is, are there any other use cases for the expando, and why should I want to use the expando? Right. Yeah.
Well, just like what I just said last, the only use cases I could find of is wherever you use a map and you don't actually have to do anything with the keys or do anything with the values. You don't have to iterate over it. You just know that you need to set a value and get it. For instance, like a cache, you don't care about the values. You don't care about the keys most times unless you want to clear the cache. Then this is a perfect solution for it. That is the only case I can think of. And if you combine it with the weak reference class, you could do it maybe a bit more. I couldn't use it here because weak reference class is limited to what you could put inside. So that's the only thing I can think of right now. Anywhere you have a map that you actually don't use and you need the values to be basically weak and not always kept in memory every time. If it doesn't have a reference anymore, it just gets garbage collected. Then this is something you should use, and it might save you extra 2 microseconds. If you care about microseconds, of course.
All right, thanks.
All right. Without further questions, I'm going to ask my own question. By the way, the presentation is over at this point. This is me just talking extra because I like to talk. Has anyone here used Riverboard? Silence in the room. Okay, 1 thumb, 2 thumbs, 3 thumbs, and the thumbs are coming in. Okay, so it means someone or some people or these people have used Riverboard at some point or are still using Riverboard. But the other question is, do you actually know how Riverboard works? Thumbs? No thumbs? Come on. Okay, 1 thumb, 2 thumbs. Okay, 3 thumbs, that's fine. Oh, a reverse thumb. Anyways, okay, more thumbs and more laughing faces. Anyways, I also use Riverboard. I have been using Riverboard myself for a very long time now. Well, not very long, just a couple of years at this point. And I really like it. From my own point of view, it is also, maybe I should add a disclaimer. I am not advertising Riverboard. I'm going to say something else. Don't take me out of context. Don't record this and put it on Twitter. I use Riverboard because it allows me to sort of think of states in a composed manner. So it allows you to say, break your states into small chunks or small sections and then compose them together. You don't necessarily see what's going on under the hood, just like much of Flutter and the whole declaration and style of programming where you just declare your widgets and it works when you click on run. But under the hood, there are elements, there are render objects that handle most of the life cycles and most of the drawing and painting and layouting. All you care about is extend stateless or stateful widget, or sometimes inherited widget, and compose it, and you get your final result. Same for me with Riverboard. You make your small states and you compose them, and eventually when you read them or watch them, something happens and your UI rebuilds. This is not a new concept. It's something that's already very well used in the JavaScript world. You have things like Jotai, if you do React or just normal vanilla. You also have Valtio, and I think one other one, Zoostand. It's a bit weird when I say all the names out like that. They sound very funny, but they're actual things, they're actual packages in the JavaScript world that somewhat looks very familiar to Riverboard. So it's not an isolated concept. It's something that you find in other, maybe only JavaScript, I'm not sure, but at least I know of it in JavaScript. And there's something about Riverboard that actually caught my eye that I've always been wondering, like, how does this actually work? So I've looked at the JavaScript implementations for Jotai and Zoostand and Valtio, and it's very straightforward. It's actually very readable if you know JavaScript, even though there's a lot going on in these days. But JavaScript itself is quite readable on its own. And if you go through these libraries, which I also share the links, it's actually readable. You can understand to an extent what is going on. In some cases, you find global states. In some cases, you will not. But at the end of the day, it's identical in terms of what it does. But there was something about Riverboard that sort of always struck me, and I will just share my screen briefly, if I could find it. I think it's this one. You could see the Riverboard docs, right? Like the website. Anybody? Yes? No? Maybe? Yes. Okay. So there was something about Riverboard. Again, I already mentioned caching, nesting, blah, blah, blah. But there was something, if you go a bit further, when you go to motivations, that always got me. So if provided a simplification of the inherited widget, then Riverboard is a re-implementation of the inherited widgets from scratch. Like this has always been like, what? Like what? Okay. And I always wanted to find out, but I never really had the time to actually look at it. Of course, there's more information here. And again, it says it again. Instead, Riverboard implements its own mechanism that works in a similar fashion to the inherited widgets, again, from scratch. But how does it do that? How is it able to actually do that and just get it to work the way it works? Because if most people, when they look at Riverboard and they see this, oh no, global. What? Global state. Oh my God, evil. But in reality, it's not. It's not global state. It's a pointer to a state, but it's not in itself this state. So that's why you can't just say counter provider, get me your state. It doesn't work that way. It doesn't hold any state. And if you have maybe one day bothered to look inside, you would see it doesn't actually do anything. It's just like a widget that just has a way to build, and it doesn't hold anything else, but it somehow knows about state and everything else. And that's one thing I found very interesting. And that led me to, I think, multiple weeks of trying to re-implement Riverboard. Yes, you heard it correctly. I tried to re-implement Riverboard in a way that actually makes sense. The goal was for me to actually see how much code I needed to write to get feature parity. And that's why, again, like I said, it's a continuous thing. Anytime I have free time, I look at it again and see what I can improve. The goal, just like the previous conversation, is not to start using this in place of Riverboard, but it's just a way for me to understand. Because again, like I said, for the JavaScript implementations, you could just go to GitHub, and most times it's one file. It could be maybe 60, 100, 200 lines, but most cases it's just one file, and you could read it from the top to the bottom and have maybe an idea of how it works. Then you run it and you put debug statements everywhere, and then you could see, oh yeah, okay, this is when it gets here and this is when it goes. But the thing with Riverboard is every time I look at the GitHub, at least before now, I was always confused as to where to start. So do I start from just the provider? Do I go in? But then I don't see anything, and I'm like, okay, I see elements, but okay, what next? Like it's a merry-go-round, and there's no actual direction on how to understand how it works. So that's why I decided to do this. And I'll also share the link. This is something I call pods, for lack of a better name. And it's almost identical to Riverboard in the sense that the API is almost identical. But as you can see, there's a warning, there's some missing things. There's no error handling at all. Obviously, you would see there are no tests. There's no auto dispose. There's no cleanup mechanism. You have to clean up yourself. Again, you're not supposed to use this. You could just play with it, see how it works, see if you could get anything from it, because yeah, it's what it is. And it is a couple of lines. It's not that much, but 800. You didn't see it. Let's move on up. And you could play with this on that part. Oh, I already opened it. On that part. And if I run this is just a console application using it. And if you check the API, there's a feature pod, there's a value pod, there's a state pod, which is mutable state. There's a future pod. I already mentioned that. There's a stream pod that allows you to push, basically, do strings. And pods could listen to each other, they could watch each other, they could watch their future, they could wait for their future. And you could also mutate state pod and something like that. And then you have logs because they're listeners that are listening to these pods and returning stuff. You also have async values that you could also listen to and stuff. That's fine. There's more you could do, but yeah, the example is very minimal. And because it's always nice to have a UI to test things, I also decided to make a Flutter version of it. And this is exactly using the same code from this, but just having a Flutter extension on top of it. So importing Flutter material. And again, the pods are very straightforward. It's better I show you that part. This is that part. There is a state pod, a future pod. You could do on dispose things when you want. Watch other things. rebuild when things change, also selectors, async selectors, normal selectors, almost what you would find in Riverpod. You could also listen to stuff, but there's a huge difference here. There are no consumers. So I know why there are consumers in Riverpod for optimization reasons, but I figured, yeah, I'm not trying to optimize anything. Can I actually do the same without and just using Builder? Because it's literally the same thing, just encapsulating your state change so it doesn't bubble upwards. And yes, you could use a Builder. You don't need consumers. And the only problem here is that when the widget dies, I sort of move to the next frame to actually remove the things that were being listened to. Unlike report and consumer, it actually happens in the same frame. And every time the frame changes, there's a cleanup cycle that removes all the previous providers that no longer have any listeners to them. But you don't have that here because, yeah, I didn't care that much. I didn't have free time. But this is where I think this is where I ended it. And this was just today. I added one more thing to it. And it's almost, again, just like Riverpod. You could watch stuff, you could, and if I run this via Flutter, of course, you could have the check, so you could see when widgets rebuild. And so you could actually see that widgets don't just rebuild themselves, they only rebuild where they're being watched and not necessarily anywhere else. And the builder helps with that, so it doesn't go upwards the tree. You also have something called pod scope, which is like the provider scope. And so you could override stuff levels deep if you want, and they will definitely get overridden. And there's more you could invalidate, just like you would in report as well. And this is what extra code that needed to be written for Flutter. There's a pod scope. It's just a stateful widget. Then there's some extra things here with dependency management and when you change overrides. And also finally, the extensions on context. And that's it. Everything else from here is exactly what existed in the previous code for just the CLI option. And as you see, if I reload this, or should I just run it again? You see the async stuff are also async. I could modify values, and whoever listens to it will also get triggered and will build only what they need to build. I could invalidate stuff, and it would get built. And same thing with stuff here. And that's it. That is all I wanted to talk about. I hope that was informative. I don't know how many people stayed to the end, but yeah, if you liked it, I will share all the links that are necessary for everything I talked about, including the slide. I don't know, the slide is very minimal, but I will also share it. And yeah, that's it. Any questions, if any, to be honest?
Jeremiah, you did inspire me. Oh. I think I will start
There
going
are
into
there are chefs and there are chefs and there are people who are trying to be chefs.
I'm telling you.
I just try my best. I'm just a guy like you, to be honest.
At this point, I don't even get bothered about what Jeremiah is doing again, and if I can do it too.
You definitely can. I have a lot of free time sometimes, so that's why. It's just time. There's more that can be done. There's more that can be researched. But yeah, 24 hours is sort of getting smaller and smaller by the day. But yeah, there's nothing special most times when you look under the hood. So my whole point of this is you could peep under the hood of things and you see that it's literally just if and else, to be honest. Okay. I don't have any soap. All right. I don't know if there's any other questions, but I think you could end the recording now. And I'll bid you guys a good evening, unless there are questions. But if there are no questions, then indeed, good. Have a good. Oh, there's a question. Okay.
Not question, just random comment, right?
Oh, okay.
This video will be available. We've made available, right? And every other related material and literature that your guns want to share with us, we'll ensure that we share it so that the soap can go around.
Okay. All right. The soap shall go around. Trust me. All right. In the absence of any more comments and contributions, you guys should have a good evening. And see you at the next one.
All right, see you. Thank
Yeah,
you
see
very
you.
much for your time.
Bye, everyone.
All right.
Thank
Yeah,
you.
bye.
Bye.
Enjoy your weekend.
Bye.
My students, where they here? Oh yeah, let's move over.